All right, hello, we are the Vulcans. Our program that we are writing is a Reconnaissance Volcano Analysis Tool, or RVAT for short. My name is Neil Turnley, and I'm the project lead.
I'm Daniel Lance, the design lead.
I'm John Breinfeld, the Q&A lead.
I'm Andrew Kerr, the documentation lead.
And our client is Dr. Wendy Borson. She works here at CWU with the geology department, more specifically with the volcanology department and studying volcanoes here in Washington. And our advisor is Dr. K back in the back there. So let's just get started. So the big problem that we ran across the first time that we met with our client, there's this program called MELTS. And MELTS was designed roughly 15 to 20 years ago over at the University of Washington. It's a program that takes in minerals that are extracted from near a volcano. And what it does to these certain minerals is it says, oh, I'm going to put these minerals under test of what it would be like down in the magma chamber. And then it outputs whatever, what type of minerals in that certain rock would melt and what would become part of the wall rock and what would happen to those specific minerals. Well, the research that they were doing here at Central needed a little bit more breadth than just one mineral sample. So that introduces a secondary program that they're using called Igor. Now Igor was developed around 7 years ago, and it uses Visual Basic and an Excel spreadsheet to interact with MELTS. And now MELTS is taking in a couple hundred now data points and outputting these results. So what it's doing is it's taking these temperatures and these minerals, and putting it at a certain temperature and then lowering the temperature and doing this hundreds and hundreds of times. What this leads to is a gigantic spreadsheet of data, and this data is just everywhere. It's huge. Most of the time she was reporting getting Stack Overflow because it wouldn't fit in one Excel spreadsheet. I'm talking hundreds of thousands of columns and rows, and it's just a mess. And what she has to do is she has to analyze this data. Well, she's spending at least 20 minutes running it through Igor and MELTS just to get the data, and then she spends an average of 5 hours going through these Excel spreadsheets and looking for the data that she actually wants to use. Now, this is a very, very time-consuming process, and so that's why she's very thankful that we're actually going to be trying to help her with that part. So this is the way, to our knowledge, what is going on and how we're basically trying to fix it. So we have MELTS over here. MELTS is interacting solely with Igor, and we are going to be interacting with Igor outputs. And Igor outputs a series of XML files, roughly between, I would say, 200 to 700 XML files per run, and she does around 9 runs a day. So it's a lot of data, and we'll look at that later in the presentation of how much data there actually is. And then we have our GUI and our database that will actually be holding this data. So our goal, she wants a tool that can be used as reconnaissance graphing. So she wants something that she can set up and graph the same amount of data every single time with all these runs that she's doing during a day, and it won't take her 5 hours to look through this Excel spreadsheet. It's all very clean, very organized, and easy to use. Not only does she want to graph, she wants it to be able to put specific data out to an Excel spreadsheet. Right now, Igor puts all of the data that comes back from MELTS and Igor into one Excel spreadsheet, and it's a nightmare to filter through, so she wants it more specific. And then advanced ease of usability, and we're going to be doing this through profiling. So we're basically going to be making a specific profile based on what she needs out of the specific run, and so she can easily graph it and look at it. Our team strategy, we've been using Agile's method. We've been having weekly Scrum meetings, and we've been meeting regularly with our advisor and with our client. We do have a prototype to show you today. We've been developing in Java and with the Eclipse IDE. And you've been using SQLite for a client-side database to store the data that comes out of these XML files. We've been using Bitbucket for our repository, Mercurial for version control, and Jira for issue tracking. Okay, and then here's what's to come in our presentation. we're going to be looking at our project requirements, what we kind of talked with our client about, and a high-level abstraction of these requirements, what you're going to be seeing in later versions of our software, and functional and non-functional requirements. We're going to be actually prototyping certain parts of our software today, more specifically the XML parsing, the use of profiles, and the graphing environment. And then we're going to be going over our QA and risk analysis regarding client feedback and risks and strategies that came with our software.
All right, so very first requirement for our project is the fact that it needs to consolidate over 500 XML files, which is quite a bit, so we need a computer that can handle that. Then another thing that was a problem with 500 XML files is the fact that she had to look at every single piece of data manually. So we need a way so that it's easy for her to find what she needs. And then basically, she also wants to be able to see it too. Graphs are always nice. She wants to be able to graph it. Usually what she'd have to do is take the data in Excel and then graph each point individually, which is a lot of work for, as Neil was saying, thousands and thousands of points. So we're going to have the program do it automatically for her. And then we want to be able to export all that data automatically out to Excel so that she can just simply open file and we'll open all the graphs and data ready to go without her having to do anything special. And then, so when she does everything, there's times when she will use the same chemicals or compounds again and again, and she doesn't want to go each time and find those same compounds. So this will have profile management that will remember what compounds she wants to use and will automatically generate that data for her. In terms of non-functional requirements, is the fact that this program has to run on a Mac. And none of us own a Mac, so something we had to do was write in a cross-platform language, which we chose Java. And they also have Macs inside the geology lab, which will come later when we talk about testing. And so that was something I had to worry about. That, and she wants it, as Neil was saying, it takes 20 minutes to run equal and all that. We wanted to get, she wants it done in 2 or less, which is another big thing we had to worry about. And then she said the most important part, the reason why they used BASIC in the first place was precision. And they needed at least 16 decimal points in precision. And right now with Java, it's easy to support with a double 16 decimal points, and our SQL believe can allow up to extended precision and up to 20 decimal points as well. And show just how we would handle that.
All right, so now we're going to go into a demonstration of the actual prototype. And all right, so initially when the program loads, you have the option to select a profile. This is the first thing and most important aspect of the program because she doesn't want to have to re-find all the information again and again. So if she wanted to, she could come over here, create a new profile, just make one really quick. And then select a profile. And it loads us into the main view of the program. Right now there's limited functionality as it's an early prototype. But in this section we have where will be our data sets. And this will be the Excel view of the entire, the data that's coming in. Basically being able to export it from here. And John will be developing this feature of our program. The next aspect is the graphing environment. This is pretty limited as far as right now, but basically we'll want to be able to select different chemicals against each other and then being able to plot them. And we will be adding a much more features to this and link it up with our actual database in the future. And then also profile information. This will be storing the actual profile specifics. The biggest thing to note here will be the specific runs of melts, and these are the actual database files that get created every time we parse through a specific run of the melt cycle. And she'll be able to add those runs specifically to each profile and then be able to later use them in both the graphing environment and the data sets. And then go ahead and show you an actual parsing of the data. We've got it set up, Neil has set this up where we have the ability to select multiple XML files. And basically it'll go through each file and parse it out to a database. It takes quite a while depending on the computer. This computer runs fairly fast. You see it's already done. There are 500 XML files for that specific run, so it would take quite a significant amount of time to do that. And it outputs it to a database. This is a view of the SQLite. As you can see, it is a tremendous amount of data, hundreds of thousands of data points, and it's just on and on and on. And so if you can imagine this in an Excel sheet and being able to simplify it down into one database, and through our ability to search through this database in a more orderly fashion, we can provide a much faster approach to getting the data that she needs. And that concludes our prototype demonstration.
All right, I'm going to talk about the quality assurance. So the first thing that we want to do is use version control. This is good for us because we have everything in a central location. Whenever we want to add and just share information, it's really quick and easy to access because it's in one place online. Also, every group member is responsible for one task, and it's known to them and the group member. This is really important to prevent duplicate work, and also everyone, since they all know what they're responsible for, it allows meeting deadlines a lot easier. We had constant communication with our client throughout the process. We met with them almost every week. And during this process, we were able to not only get the requirements, but also show what we had done to them and to get their approval. So the first, we had a throwaway prototype of our GUI. And this was good because it let us know that we still had some work to do. We did not quite meet their expectations. We had to make some adjustments specifically to our graphing. I envisioned just graphing one chemical against another, but in reality she wanted multiple chemicals and runs against each other because that was what was useful to her. So we had to make adjustments in that. But in general, our proposed solution was what she wanted, and we even suggested things that she hadn't quite thought about, like exporting the data to Excel and her to be able to organize it that way. There are some risks that we're going to have to deal with. One of the main ones is parsing the data. As you saw, there's a lot of data, and it takes a lot of time to insert it into the database. A possible solution is to use the geology department servers, which are a lot faster than a normal computer. This will allow that to be done way faster. It could be hard to test our program just because it has such a large back-end and complicated data sets. So a possible solution is to use mock objects and dummy data. It'll reduce our testing time and make it a lot easier to test. Also, our program, as stated before, needs to run on a Mac, and so since we're writing it not on Macs, we have to make sure that it's compatible with the client's software. So we're going to test on their computers in the geology department just to make sure that what we're doing is actually compatible with what they have. That's conclusions.
All right, so in conclusion, our solution is RVAT, and basically we're providing a solution that is a huge time saver for the geology department and anybody analyzing the volcano data with melts. We want to simplify the data storage because right now there is a single Excel file and like 500 plus XML files. So by reducing that down to a single database for each run, it'll greatly reduce the amount of storage. And also providing that environment where she can go ahead and graph and analyze the data very quickly as opposed to having to manually pull out every single point will greatly reduce that time spent. As far as our team progress, our process has been working fairly well. We've been meeting fairly consistently, and so far we've been working well together. We feel like we've hammered out our requirements fairly well from our client. We understand the problem and know where we're going to be headed. We're hoping to advance some of the other things that she wants to add to the program as well, as our development so far has been pretty good. We have the back end mostly done and completed, so it's a good starting point going into the next quarter. So, are there any questions?
You talked about 16 decimal places of accuracy.
Yes.
How are you guaranteeing that?
A double has 16 places of 16 decimal places of accuracy. So as long as we ensure that everything is, Mel's already has 15 places. So as long as we ensure that we continue using doubles and
Double precision.
Yeah, double precision. And
What kind of manipulation, if any, do you do with the data?
None. We're basically just taking this data out of what Igor spits out into XML files, which are already down to around 16 decimal places, and then we're putting them into a database and then plotting them.
If we have enough time as possible, that we will do some calculations. She does them manually, and if we get everything else done, that's a possible extra feature that we could add.
Then I would encourage you to be careful.
Yes.
It's easy to lose 16 decimal places once you start manipulating.
Yeah.
How do you, or what if you cannot design your system so that it can process those 500 or batch of 500 files in less than 2 minutes?
Right now, a modern computer with, let's say, a Core i7 processor can do it in around a minute. The ones up in our labs currently takes about a half an hour. Our solution to go around that is going through the geology servers. And so we're parsing the XML files out and putting them into a database server side instead of client side, and that's going to cut a lot of the time down. So I'd say the majority of modern computers can do it pretty quickly, but we're only worried about if the technology is way in the past, that it would definitely take a while.
And so you have communicated this to your client that you're
Yes.
expecting it to be run on.
Yes.
All right, thank you, Matt.